So there are the BoPs for today with the answers in orange. Okay, now let's move to the notes. So your 2-1 study guide, beginning of chapter 2 here. So this is going to be a pretty quick chapter, I think. If I remember right, it's just like 2 weeks. Might be a little bit long. A little over 2.5 weeks, I think. We'll be on this, and then we'll take another test. Okay, so we're starting by just defining some numbers. So nothing that you haven't seen before, but I don't know if you've actually learned what their specific names are for these groups of numbers. So whole numbers first are just the numbers that you started counting with, like 1, 2, 3, but then include 0 with it. Those are called your whole numbers. Okay?
Yes.
Integers are all of those numbers, but including your positive and negatives. Okay? Are we good? Then rational numbers. This is where it gets a little funny, I think. Because by definition, a rational number is any number that can be written in the form of a over b, or basically it's just that can be written as a fraction. So you have to kind of think, it's like, can these numbers up here be written as a fraction?
Yeah.
Yeah, if you put it over a 1, right? So like if I have the number 9 and just put it over a 1, that's a fraction, right? So integers and whole numbers are also rational numbers. But also we get into where we have like decimals, like 7.9. Can that be written as a fraction? It can. So 7.9 is the same as 79 over 10. So check that on your calculators. Do 79 divided by 10. It's 7.9, right? Okay. And then the next one that they put in the example, 2 and 5/8, that's obviously a fraction. Now the next one. So it's 9.368686868. So do you see that this 6/8 part is repeating? Okay, so that also can be written as a fraction. It's definitely not as easy to just switch it. Like this, I knew that it was, we would read this as 7 and 9/10, so it goes over 10. This is not as easy to, there's a whole process, and we're not going to get into that. But something like if you did 2/3, so 2 over 3, right? And change that to a decimal. It's 0.666666, right? That's a repeating decimal. Okay? So it can be, when there's repeating involved, it can be written as a fraction. So really a rational number is a fraction, a terminating decimal, or a repeating decimal. Kind of squishing that stuff in there. So it's a fraction. And of course, our whole numbers can always be put over a 1 to turn them to a fraction. A repeating decimal or a terminating decimal. So terminating just means that it ends, right? So all of those are rational numbers. Then we come to irrational. So it kind of sounds like it's the opposite of rational, right? Well, it is. It's the one thing, the one type of number that's not included in those rational numbers. And that's when you have a decimal that does not terminate and it does not repeat. So it basically goes on forever without any pattern going on. Because you see these? There's no pattern here, right? They're just a bunch of numbers after it, but nothing that I can say that it's a pattern that's repeating. And the last one, real numbers are everything from above. It's all your rational and all your irrational numbers. So what's the opposite of something being real? Fake? What about, let's see, let's play a game. Fake would kind of be right, but it begins with an I, the word I'm thinking of. No. Imaginary. So there are also something called imaginary numbers that you'll start to deal with next year. But that's why we have this group called the real numbers. Okay, these are everything that we're dealing with here and you have dealt with in the past. Imaginary numbers help us deal with something like the square root of -1. So do the square root of -1 on your calculator.
What is that?
Yeah, math error, right? So in higher math, we have to be able to deal with this square root of -1. So they deal with it by calling it an imaginary number, and it gets its own variable called I. Okay? Now, that's just fun stuff to think about for later. Other than that, put it away. We're not going to deal with it. Okay? But I kind of feel there's a reason we have this group called real numbers. It's because there's also something called imaginary. Okay. So every real number corresponds to exactly 1 point on a number line. The distance between those 2 points is the difference, the positive difference between their measures. Or we can just count them. So if you're asked to find the length or measure, one of the ways we can do is count it. I'm going to show you another way too, but one of the ways is to just count it. And it must always be positive. Okay, so let's go wrap our mind back to these numbers. So it says for each situation, write a real number with 10 digits to the right of the decimal point. Ooh, with 10 digits to the right of the decimal point. Okay, so I'm just going to draw a number line up here real quick. I'm going to go just 1 to 6. 1 to 6. So that's -6, that's +6, and then we can count them in between, right? One, two, three, four, 5, 6. Okay, so draw a number line on your paper. Okay, so number 1 says that they want us to write a rational number. So we have to come back up here and think it has to be a number that can be written as a fraction, a repeating decimal, or a terminating decimal between 5 and 6 that terminates. Okay, so they want us to write a terminating decimal between 5 and 6. So it has to be in between here. So it's going to be 5 point. And then you know what? I'm going to change this. See where it says 10 digits? Let's change it to 3. I just don't think we need to write 10 digits. It's a little excessive. So, terminating decimal with 3 digits after the decimal point, 5.412. Could be anything, as long as there's just 3 numbers after that. And nothing after, no dots after it to say it goes on. It's not repeating anything, any sort of pattern. It's done. So I'll just put or ... meaning there's like lots more things that you could have there, right? Then number 2 says an irrational number. Okay, irrational means it's going to be a decimal that does not terminate or repeat between 1 and 2. So that means what's my first number going to be? A 1. Irrational between 1 and 2. Okay, so that means it can't have any sort of a pattern. So 5, 6, 3, 4, 9, 8, 2, ... I did more than 3 digits just to emphasize that there's no sort of a pattern that's going on here. You should have the dots after it. Usually it's 3 dots. I got carried away. Did more. Yeah, having at least 3 dots after it means it goes on forever. Okay? No sort of pattern. So these numbers back here could be anything, as long as there's no pattern involved in them. Okay. And then the last one, a rational number between -3 and -2, so it's there, with a 3-digit repeating pattern. Okay, so what's my first number have to be? If it's in here. Remember, we're counting this way. So this is -1, -2. So we're -2 is all the way until we get to -3. So it's going to be starting with a -2. That's why looking at the number line will help us there, because sometimes you think, okay, but if it was positive between 2 and 3, it'd still be 2, right? Because it's negative, sometimes we think it works backwards. And then we have to do a repeating 3-digit pattern. So give me 3 numbers. 3, 2, I want a different number than 3. 4. And then if I were to keep writing it, it would be 324, 324, ... right? Or we can write this as -2.324 and put a bar over it. That bar means it repeats. Okay, any questions on those? Okay, so this is part of what your assignment today is going to look like. It's going to be giving you some information about the type of number that they want you to write. Okay? So what's going to happen is the numbers after the decimal point will change. They won't be the same for all of you, your answers will vary from what's in the book, but the number in front should be exactly the same. And if the answer ends, your answer should end. If it goes on with dot dots, your answer should go on with dot dots. And if it's repeating, you should see like a repeating pattern or repeating bar. Okay, does that make sense? Because you may not see, in fact, I could guarantee you're probably not going to see the exact answer in the back that you're going to write down because there's just too many variations that could be put there. Okay. So the next part is actually finding the length of segments. Which, remember what we said just a little while ago, it always is positive. I like to say, like, because sometimes if we're going like from a positive 1 to a negative 3, we think we have to go negative. But the length of that segment is positive. Because you think, like, if you live 5 miles from school, so you drive to school, you drive 5 miles, right? Now, when you drive back, you're going the other direction. Do you drive a negative 5 miles now? No. Length has no direction. It's just how long is it. Okay? So if we're asked to find the length of HI, so when you have 2 capital letters, so 2 points written next to each other like this without a comma, that notation means that they want us to find the length or the distance between those 2 points. So between H and I. How can I do that? Just count them. Count them. How many are there? I heard 3. Is everybody thinking 3? Okay. You did. I'm sure somebody made the mistake I did to begin with. You're not counting each little thing. You got to look at it because they've marked the halfway points also. So you can only count the whole numbers, and it's the spaces. So that's 1, 2, 3. Okay, so let's look at AD. So starting at A and going to D, if we start to count them up yourself. 7? So go ahead and do the rest of them real quick. Count them up. There's some that are like at a halfway point, so make sure you consider that. So you can probably imagine that if we start to get numbers that are really large, like if our number line went from negative 100 to positive 100, and we had some numbers somewhere in between, it's going to be kind of hard to find exactly where they go, right? Yeah. Okay, so let's go to the back. So we're just flip this up like this. You're going to glue these in your notebook in a little bit, but you can kind of just put them up like this. So to find the distance between point A and point B, we can always count them. Well, maybe not. What if they're decimals? What if they're at a point like 1.23 and the other one's at the point negative 5.4? That's going to be hard to count, right? So there's an algebraic way we could go about it, and it's this. This is what we're going to use for our like little formula. A minus B. So the point where A is minus the value where B is. Now what I got these kind of straight bars sitting out here. What are those?
The lines,
Yeah, what are they? What do they mean?
like,
Begins with an A.
area.
Absolute value.
And what absolute value does, when we put those bars on it, it means take the positive version, I'm going to put value, of the number. So that's what absolute value means. It says whatever's inside is going to come out. We'll drop the absolute value bars and make that number positive. If it's already positive, it stays positive. If it's negative, it turns to positive. So what if I have something like this? There's a whole bunch of spaces in between here. I'm going to only indicate the ones I want to look at. So I have 2 points, A and B, on a number line. One's at negative 41 and the other's at positive 62. Definitely don't want to have to try to count those, right? So we're going to take, what point is A at? Negative 41. Minus, so we're going to use the minus from the problem, from the formula, and B is at 62. So now what is negative 41 minus 62? So absolute value bars work kind of like parentheses in the fact that you have to simplify inside them first, okay? So negative 103, absolute value of that. So we're going to take the absolute value, which means those absolute value bars go away, and it becomes positive 103. Okay, what if I have point C here at negative 20.3? And I want to find the length of AC. So that's going to be, we're going to do A minus C, negative 41, and then I'm going to subtract, that comes from here, right? And what am I subtracting? Negative 20.3. Put that in parentheses so I didn't lose that negative that went with it. But now what happens? Double negatives changes to addition, right? Adding the opposite. So what do we get there? Negative 20.7? Is that what you got? Finish it up. The length of segment AC is going to be 20.7. So, like Gabby, the one that you were asking about with the decimals, that's why I was saying I'm going to show you a way. So it gets confusing when you've got decimals that you're counting. I mean, you can do it, but you really have to concentrate to kind of make sure you're, hitting the right spaces. So if we just take those two decimals and subtract them, take the positive value, makes it so much easier. I mean, even with some of the ones where they were like 18, a length of 18, it'd be easier just to to subtract the two numbers and take the positive value, right? Okay. The one thing you have to be careful of is when you're subtracting a negative number. So always write your values down first so that you can see what that's happened. Okay? Any questions? So these notes will be in your notebook. So now it'll be 2-1, real numbers and number lines. It's just the title of what the study guide is on whatever your next page is. And then the assignment is back here on the board. It's also on Google Classroom. But it's page 55, 11 through 33 odd. So why did I give you odd numbers? So you can check your own answers, okay? It doesn't do you any good at all to just write them down, right?